Yes, so we are live now on Facebook and everywhere. Okay, so Sajjad, if you want to add anything?
No, we start.
Okay, so first of all, let me share my screen. Okay, so in last class, what we have done is we have covered most of the fundamentals of Solidity, and we also covered the basic contract creation with the new operator and without new operator. These things were already covered. Today, we have to move towards the inheritance, and what we have need to understand that what we are trying to do is we are trying to implement this, use the Solidity, the inheritance and everything. We are not going into the details of how object oriented itself, the basic fundamentals of object oriented and complete details of how object oriented work. We are not going into that detail, but how the inheritance with the Solidity and all those things will work, that's what we are going to cover. So it will definitely be most of the part, but we will not go into the minor detail of the object oriented programming. Okay, so the basic contract creation, we have already seen the inheritance. Uh, Inheritance, the basic in the basic term, if you understand, try to understand what inheritance is, it is everything you inherit from your parents. Like in the proper in case of property, in case of any features you receive from your parents in the real world. In software world, it's if you wanted to use or implement the same functionality with our objects and our classes. So in object oriented programming, we use inheritance to implement such type of functionality where you can inherit something from your parents. In Solidity, because Solidity is also fall into the object oriented language with some caveats. So we also implement contracts in an inheritance way. We can do that. For that, let's say if you have a contract C, so that's a contract. You can use that contract and you can deploy that contract and call its function and everything. It will be available on iteration and everything. But what you can do is you can also inherit that contract from into another contract, like here, contract C, contract E is C. So basically, we are saying it is called a is a relationship. So each programming language has a different way to inherit a class. In Java, you say extend. In C Sharp, there are different languages and all have different syntax to inherit the parent class. In Solidity, what we say contract E is C. So we are saying that E is inherited from contract C. So all the features and functionalities of contract C will be available inside the contract E. Now, the good part is we'll only deploy contract E, and everything from the contract C will be available in contract E from the C. So we can call all the functions which is only available in C, but because of the inheritance, they are all available in contract E as well. So that's how you inherit all those things, and all those features from the parent available to the child, and child class can work on those all those functions. We'll see how the private, public, and internal properties gives the differences when you inheriting from a contract. So that's what we need to understand. So what I'll do is, first of all, let's go for the and so basically it has all this all those functionalities we need to use. So I'll just copy from them, because private, public, private function, private variable, it has all those things. So I'll just copy them, so it will cover all the features we need to discuss within the inheritance. Okay, so first of all, what we need to understand is we have a variable which is private, uint, which is data. That we have another variable info, which is public. We have a constructor from Solidity, I don't remember exactly, but maybe 6 or 7, we don't have to write the public keyword from constructor. So if you following this tutorial, so there are many features which are old. So okay, the private function increment, there is a function which is private. Private means, as we have discussed in our previous classes, that it will only be available inside the contract. You cannot access from outside. The update data, which is public. There is a get data, which is public also, but it's a view, and update data, it's a kind of a transactional function. Compute, again, it's a function, but it's internal. The access modifier internal means it can only be accessed from the child class. So these are the functions we have, and we'll try to call them. And the contract E, so what I'll say is B is inherit from A, and I'll use all these functionalities just to show. For now, I'll just ignore this instance creation because we already have it. Let's just remove it. Okay, so at this moment, what we are trying to do is we have created a function in the child class, get computed result, and what we are trying to do is we are calling the compute function, which is available from the parent class. We have also created the get result function, which is a new function, and this function will just return the result variable. So that means get result function is a new function in the child class. Get computed result is also a new function. Compute is available from the parent. Get data is exactly similar to the parent class, so it's kind of a overriding, and it will not work at this moment because the way now the override works is different. So we'll receive the compilation error if we try to access at this moment. So let me just show you what will happen if we try to compile this code. You see, it says trying to override non-virtual function, did you forget to add virtual? And here it says trying to override. So just to, because I'll include this information later, so I'm just commenting out. So first we should learn how the inheritance and all this function will work. Then I'll explain the virtual and override everything. Already in use. Okay, so there was some other connection already open. Okay, so we have node started, we have compiled the code, and at this moment what we can see is we have a contract A and we have a contract B, and contract B can access few of the functions from the parent class. So in this function, if I'll try to access, because B is a child of A, if I'll try to access the increment function in the child class, it will give me error because increment is a private function. So that private function will not be available in child or whatever, wherever. If we try to deploy and if we try to call it inside the script, if we'll try to call from here, it will also be not available because it is a private function. if we'll try to call the compute, which is an internal, if we'll try to call this public get data, there is no error in this case. So also, if I try to access, let's say we have a 2 variable data and private. So data, sorry, let's access the info first. Because it's in a state level variable, we have to call it like this dot info. So we can call the info function, which is public variable. But if we try to call the data, that it will give us error. So for the first thing, if we are inheriting a contract from another contract, we can access the public functions, internal functions from the child contract, but we cannot access the private. Whatever the privately available will not be accessed inside that contract. Now, if I try to create another contract, see, and we are not inheriting it from anything, just say check function. Don't know what to call it at this moment. Okay. Now from here, if I try to create instance of a contract B, I'll say P dot compute should not be able, we should not be able to access, let's call it, it will give us, it should give us an error. Okay, so compute is not available because compute is internal, access modifier of compute is internal in contract A. So when we inherit a B from A, then compute is available inside the B contract, but outside of the B and outside of the A, compute is invisible. So here we can see inside the contract C, which does not belong to A or B, but we are just trying to create instance of a B. So if we try to access this compute variable, it will give us an error because it's an internal variable. It's an internal function which can only be available to child functions, child contract, sorry.
So not the grandchild, just child.
No, if it's available in the grandchild, it will be accessible inside the grandchild as well. So if we create another contract D which inherits from B, that will also be available inside that. And again, increment will not be available as well because it's a private function. And all those public functions, let's say the get data, we don't have an issue with calling this function b.getData. So public, why we have an error, the get data not found. Okay, so it's a spelling mistake, data. So the first thing we need to understand all these minor things related to the access modifiers, what access modifier connected to the variable or function available to which part of the contract. So private will not be available anywhere, even in the child. Public will be available everywhere, even in the child. Any other contract outside of the contract where we'll be calling it. Internal will be available only inside the child contract. So we can call them inside the child contract, but we cannot call outside of the child contract or the parent contract or the outside the world from the from our script where we'll try to access it. Internal function will not be internal function, and variable will not be available from there. So that's the one thing related to the inheritance which we need to understand. Another thing is, for that what I have to do is, if we create a variable of a B contract, then it will be the what you call transactional function. So to avoid the transaction and see the result directly, what I'll do is I'll create the just a moment. Because at this moment, if I'll try to call this check function from our script, it will be a transaction and will not be able to get the result properly. So that's why what I'm trying to do is I'll create variable B and I'll call the constructor. Inside that constructor, I'll initialize it. And I'll remove this from here. And this get data function returns data. Sorry, just a moment. Okay, so we'll return the static value 45. Now from the script, what I will do is I deploy only the contract C.
Sir, how you solve this error at C,
Which
type C? Sir,
you just press the control enter. It's just the inheritance error. Sorry, import issue. So if you have to import these classes into your contract. So in your script. So when you press control space, it gives the list of the properties which is available you wanted to inherit from where. So just either you can write it directly, or you can just use the IntelliSense. It's facility provided by the Visual Studio Code, so we don't have to worry about it.
Sir, I faced lot of time with this error.
The only thing you need to understand is whatever script or whatever file you wanted to use inside the TypeScript file, you have to import it. It's a class. You have to import it, and import will be done like this from here. This is the way to import a file. Either you type it manually, or if your IntelliSense is working, then sometimes it doesn't work. So you have to type it manually. Okay, so just to show you again, what we are trying to do is we have created a contract which is using the contract B. Contract B is inherited from contract A. The get data function we are trying to access is available inside the contract A. What saying can be restricted to POs. Okay. So get data function is available in contract A. So when we call it from the reference of contract B, that means we are using contract B and trying to access a function which is from contract A. So that's how you can see the properties and functions inherited from contract A into the contract B. And when we'll call it, it will work just fine. So let me. Okay, so it's returning something. 45. So what we need to understand again, the concept is very simple, but sometimes we mixed out that where the function is coming from and where it is inheriting from. So only thing we need to understand that we are creating contract which is inherited from another contract. So the get data is inherited into the contract B, and with the reference of contract B here we are calling b.getData, and it is available. That's the simple thing we need to understand it. Another thing what we can do is, let's say we say a variable A, but instead of but before that I need to just show you one more thing. With the B, what we can do is the function available inside the B, which is get result, which is easily callable from here, because we have a variable of B. It will not give us any result. Just wanted to show the result of compile there. That's what you find. Okay, so it's just a warning, ignore it. Its compilation is working fine. Now if I try to do this, what I did is actually I created a variable A, and inside this variable A, I am initializing the contract of B, because B is inherited from A. So we are using the variable type of A, and we are providing the instance of a B contract. Now from here, if we try to access A.getResult and B.getData, we will get the error on the get result, because get result is, we have an instance of contract B, but from the variable standpoint, we are using the type of A. Inside the A, we do not have any kind of get result function. Because of that, we will not be able to call the get result function, but we will able to call the get data function. That's the basic thing we need to understand from the perspective of inheritance. And this is also when I'll show you the virtual and override, then we'll move into the polymorphism structure, and I'll explain that as well. So at this moment, this is what it is, and I'll have to move to the virtual and override if you have any questions, so we can answer that, and then we'll move to the virtual and override.
Yes, sir. I want to ask something.
Yes.
Sir, uh, can we make a situation like a contract A is inheriting contract B and B is
Mhm.
inheriting contract A?
Mhm.
Like,
You are trying to cycle it.
yeah, yeah, yeah. Is it possible?
Uh, didn't try this kind of definition of base has to proceed. Okay, so in case of what it's trying to say is that the class, the contract you are trying to inherit should be available before the contract B. So if I'll try to go over there, then it will give us error in.
So, it means it's not possible.
Sir, since
Even if we go with even if we go with the separate classes and separate file, importing the separate file, it should not be possible. I haven't tried, I haven't gone that while testing those functionalities, so it should not be able to give us something, and it should be the error in all the scenarios if we try with any type of creating the separate files and all those things. But
Yes, sir, because
you should try and let me know.
yeah, because it is saying that like one contract should be, it can't be used before you declare it.
Yes.
So in any case, we have to declare one contract first. So which
Yes.
is okay. Thank you, sir.
sir, I want to add into Ali's statement
Mhm.
that since Solidity is similar to execution in JavaScript, but since JavaScript has the asynchronous capability and Solidity didn't, so uh, before we can do cycling in the Solidity. First,
We cannot do.
we cannot do, yes.
Yeah, and another thing is if I put this contract A into a separate file and contract B into a separate file, when I import the file, when I import a contract into a those contract will be part of that particular file, and then it gets compiled and all those things will be done. So the contract A will become a part of contract B, so it will be like a single contract. So that's why this cycling should not work, but I haven't gone that wild. Okay, so now that's the simple thing related to the how you do the inheritance and all those things. The another thing which basically is not available here when we try to the get data here, and we're trying to override that get data function, because previously, before, I don't know even by if it was even possible in Solidity 5. So before it was not the problem of, because virtual and override keyword might I think they've introduced in Solidity 6, I guess, the virtual and override keywords. So to override a function, previously you just name it similar to like this and it will be overridden. But now it will give us an error that you cannot override a function like this. If you wanted to override, you have to override a function. First, you have to make that function virtual. So now this function is virtual, and now I can override that function inside the child contract. For to override inside the child contract, I have to name it. I have to give another keyword over here, which is override. Okay, so now, so just to show at the basic level, let me remove those keywords. So the get data virtual and then get data override. At this moment, it is asking that your function is as a view level accessibility, so you can make it pure or something. Now this is working fine. Now at this moment, I have removed this pure or view property from the top of the contract. I'll explain it later in a moment. But at this moment, what we need to understand is we have created the get data function with the virtual keyword, and when we wanted to override in the child contract, we have to call it override. We have to implement or name everything same, which is called a function signature. What is included in the function signature? The function name and the return type. and even also the access modifier as well. So if we have implemented a function get data with the public access modifier and it returns int, so we cannot say that return bool. It will give us an error. One thing. Another thing, if I'll try to make it internal, it will give me error because visibility is different. If I try to make it external, it will still give me error. So I have to make it same. Okay, so that's one thing. And if we wanted to access that function, I'll explain this pure and view difference once I'll show the example, because if a parent function has a pure keyword, then you cannot make it without pure. So I'll explain it once I'll show the example, then I'll explain it. So get data virtual and get data with the override. That's how you do the overriding in the contract. Now what I'll do is I'll comment out over here B. That does not matter to us at this moment. Okay, just keep it this like this. So if you see, what we have done is at the variable level, we have the type A and type B, but instance level in both cases, we have type B. We do not have type A or we do not have type B anything. So the instance, both instances are B. Now what I'm trying to do is in check function A, I'm trying to call A.getData, and in the check function B, I'm trying to call the B.getData. Because of the inheritance, the get data should be called from the contract of B. You see, we have both the function A and function B returns 5. If we go to the contract, the function get data from the class A, contract A should return 45. The get data from contract B should return 5. Here we have variable of type A and type B, but both have the instance of type B. So because of the inheritance and the polymorphism, when we have a parent reference and the child object, whenever we call a function which is available in both class, which is we have overridden, it will always call the function of a child class. So it will be a child contract in this case of Solidity. So whenever we call it, it will always call the function of a child class. So reference of a parent and the object of a child. So we have a reference of parent and object of a child. Even in this case, when we call A.getData, it calls the get data of B contract. So it calls the polymorphism, it calls the lead binding, and sometime in the informal term, we call the calling of a function at the runtime. So it identifies the function at the runtime. That's why we call it lead binding. So that's the polymorphism, and that's how the inheritance and virtual work. So whenever you wanted to create a function, which needs to be overridden, and you will see a lot of these implementation in the when we will go for the implementation of the ERC20 and ERC721. We'll use the Open Zeppelin. So Open Zeppelin have given us a lot of functionality, and they have given us the virtual functions, so we can override those functions with our implementation. So we'll see those in action in actually when we'll use the ERC20 and 721. So at this moment, we have touched the all the inheritance and the polymorphism with the virtual and override keyword. If we have any question at this point, please shoot out. Then we will move to the next.
Sir, I have a question.
Yes.
Why we are using like
Why?
why we first you take what can I say? Why we are using the like you take a variable as a type, a contract, and why we are keeping the instance of class B, like a B
okay.
contract?
Yeah. Basically, it will. You can only understand when you have a project which contains functionalities with the multiple entities that belongs to a single parent. So forget about the Solidity for a moment and think about the domain where you have a let's say student management system. So you have a student, you have a teacher, you have a principal. All these things relate. They are all human, and they have few similar functionalities like name, age, email address. So what we do in object-oriented programming is we create a parent entity, which is generalized entity. We call it generalized, and we'll name it in human. And then we'll inherit that student, child, student, teacher, and the principal from that what you call a human entity. Once we do this, what we have all this functionality from human, so we do not have to reuse the code first. So we have the code reusability from the parent. So name and age and properties came from the parent. Now what we can do is, let's say in some of the functionality of our project, we require the question someone asked before we started the class, that I wanted to return a type. Sometime I wanted to return a variable, and sometime I wanted to return different type I wanted to return. So we are accepting we can what we can say. So just for the example, in the class, a principal can enter, a student can also enter, and a principal can also enter into the class. So what we can do is we can create a function which accepts the human. Instead of accepting a student, what it will do is it will only accept student. So we cannot send the teacher in that function. To understand this, what we'll do is we'll create and we'll say, just for the example, it does not belong to the Solidity at this moment. So I'm accepting the human. Now this function, in this function, we can send the instance of teacher, we can send instance of a principal, we can send instance of a student. So all three can come in. Same thing, this is the same functionality and feature can be used with the contracts. If you have a multiple contracts which have some parent functionality, and then we have a child contract which are depends on the functionality of a parent. So we can use this kind of functionality, that we can change over between the contract and use the functionality from the contract. Then we'll have this functionality, and we can use this in case of inheritance. But definitely in that case, your domain needs to be that much of complexity. If you are creating a simple NFT token or ERC20 token, then you will not be able to see these things in action. Okay, so we have covered in detail at least that how the inheritance will work, how we'll be calling the public, private, and internal functions from the child class. Private will not be available, internal will be available. And we have also seen the virtual and override. So when we wanted to use the polymorphism, we wanted to use the override a function of a parent class, we can override it easily. With for that it's not available in this tutorial because it is related to the Solidity version 5. We are working on the 8. Okay, so that's one thing. Constructor we have already discussed in detail in multiple cases, that when we have a wanted to call of whenever we have a contract or an object at the deployment or at the initialization, at the time of initialization, we wanted to put provide some arguments, to provide some values to initialize that contract. So we can create a constructor and do all the functionalities which we wanted to do right at the initialization of our contract. So for that we use the constructor, and constructor can accept whatever the parameters we wanted to. Let's say if the contract B then what we in the constructor what we got given 256. Now when we create the instance of a B, it will ask us the argument. So we have to provide this value inside this contract. So let's say I'm providing 9 and here I'm providing the 12. So whenever you initialize an object, in our case we are actually creating a contract. Creating a contract means we are actually deploying that contract on the blockchain. So whenever we try to deploy the contract, it will call the constructor. And in that constructor, whatever the argument we need to provide, whatever the functionality right at the deployment time. So it's an initialization of your object. So whenever you wanted to initialize, whatever functionality or the statement or anything you wanted to do at the initialization, you will do inside the constructor. Constructor does not return anything. That these are the some basic information that constructor does not return anything and all those things. Yes, someone has raised the hand. Okay, so let me just move to another file to show. Okay, so when we create a contract and we do not provide any kind of a constructor, then environment will provide the empty constructor to the contract. That will be like this. If we do not create the contract, if we do not specify explicitly, it will be available into the contract and we do not have to worry about. That's why we will be able to call it like this. But if we provide the constructor, then we have to call it. Let's say I have created a constructor. Let me create that constructor in the child class.
So, sir, the constructor initialization will be by default.
Constructor initialization. Whenever we deploy the contract, it calls the constructor.
Okay, sir. Thank you.
Okay, so here in this case, we are trying to create the instance of a contract B. It's asking for the argument. So that's the simple thing. Why it's still the error function declared as a view. Okay, so that's the simple thing. But if we do not provide constructor in child and provide constructor in parent with the argument, it will give us an error because a child class has a constructor like this, and it calls the constructor of a parent class like this. That's the default implementation. You don't have to do anything for that. That's the default implementation. So if you do not provide anything, you will have this implementation constructor, and it calls the constructor of a parent class. So if I be providing the value like this, and if I do not provide anything in the contract B, so actually we have this. And in this case, it is calling the empty constructor of a parent, but parent does not have an empty constructor. So what we have to do is we have to pass value from here like this 3 or anything. So that's how we can call the constructor of a parent. So if parent has a constructor which has an argument, then you have to call that constructor from the child. Otherwise, it will not work. It will give you the compilation error. That's the simple thing about the constructor. Other than that, everything is similar.
Sorry, sir, to interrupt. When you declare the function check function as a view, and you pass the argument 2, although it does not change the contract constructor in the contract A, and it does not change the state variable, why does it give the error of
basically we are creating a contract. It's actually the changing the state of a blockchain. So it's the it's not a view function. It's actually creating the transaction because it will deploy the
sorry, I didn't think about the contract.
okay,
Thank you.
so is it clear at this moment? Just let me reiterate that if you are trying to call parent, if your parent class has a constructor which has an argument which accepting the input from in the constructor, then in the child class you have to provide that constructor like this, and you have to specify the parameters whatever the parent class asking. So when we create the contract B, it will go from here to this constructor, and it will call this contract constructor. So this constructor will get called, and then this functional implementation of this constructor will get called, and then the deployment will be done. So that's how you go the constructor in the case of inheritance. Otherwise, calling a normal constructor is simple. There's nothing much into it. Any question over there? We're moving to the abstract contracts.
So sir, we can pass.
Yes.
Sir, we can pass the parameter as in this contract B, or not?
Yes. So let's say if I say 2. So at the calling time, I'm passing 2 over here, which will go to this at this point, and this B will go over there, which will be available here, and we can use it.
Okay, thank you, sir.
Okay, now in case of abstract contracts, so basically what we have to do is sometimes we have the parent-child relationship, but the implementation in a few of the functions have the implementation, but some of the function needs to be implemented by the specialized child classes. For that, what we have to do is we can create a contracts, contracts, with empty implementation. So let's say I have a contract, I'll say get data returns u in 256, it will return 45. That's simple. But one of my function which does not have implementation, you see, just let me for the moment. So you have a function which is not implemented. It's an abstract. So what we are expecting is a child class will come in and child class will provide the implementation of this function. Now, if you are give the empty implementation, then that means you are not giving any implementation. You are marking a function as an abstract. For that, we have to mark our contract abstract as well. Previously, it was not the restriction, as you can see over here. Because in the previous version of Solidity, it was not a problem. So if you are following this tutorial, you will miss this thing. So what we have to do is we have to mark this contract abstract. Then this will work fine. Function with must be marked virtual. Okay, you have to also mark it virtual as well, because child class will come in and implement it.
Sir, what if a child class doesn't give any implementation of the abstract function?
Child class will also be needs to be abstract, as you can see at this moment. You see, contract B inherited from contract A, but does not provide any implementation of get result. So here you can see contract B should be marked abstract. So there it is asking that it should mark abstract. If you try to compile it, it will give you the error. As you can see, the error is here.
Okay, thank you, sir.
So you have to mark, either you mark it abstract as well, then it is fine, but you cannot. Definitely, if a contract is abstract, then you cannot create instance of that contract. It is not allowed. Cannot instantiate an abstract contract because contract is abstract. So at this moment, we do not want to make the contract abstract. So what we'll do is we'll implement this function. And instead of saying virtual, we'll say override. Now we can create instance of a contract B, but we cannot create instance of a contract A because contract A is abstract. Abstract contract cannot be initialized.
And it will give the error at runtime.
At the compile time, not at the runtime. So cannot instantiate abstract contract. So we cannot deploy contract A, but we will be deploying contract B, and all those functionalities of contract A will be part of the contract B. So get data will be available in contract B, and we'll use the contract B as we use any other function. So that's the abstract contract concept, and it covers all the virtual and overriding functionality which we discussed in previous examples. Any question over this?
Sir, instead of using function, can we use just the variable, or then call this variable anywhere? As you know, as you say that a variable is a function, get function. Function is doing just as a variable which is returning the value.
No, basically the variable is a different thing. You cannot mark a variable as an abstract. Abstract will be marked by only a function, because functions have the functionality. It have multiple statements and expression and everything. So what you wanted to do is you are saying that I will not implement this for function. All my child classes, specialized classes, will provide implementation based on their needs. So they will implement based on their needs. You just have to give the empty implementation. So variable does not it is not coming anywhere near to this feature. So you might be mixing something. Any other question?
So, sir, abstract contract is the one like if there is a contract, it is having 4 or 5 functionalities, but 4 are implemented and 1 is not implemented. So we have to mark that one as abstract, yeah?
That contract will be the abstract contract.
Thank you,
Even
sir.
if a single function is not implemented, or what you say, even if a single function is an abstract, whole contract will be marked as an abstract, and you cannot deploy that contract, you cannot initialize that contract.
But that contract, that abstract contract can be inherited by any other contract.
Yes, that's the basic feature of the object-oriented programming. So that's the needs to, that is there because of this functionality, because child class will implement that that function which is abstract in the parent class.
Thank you, sir.
Sir, I have a question.
Yes.
Sir, we are talking about inheriting contracts. So, so you already explained, when we inherit a contract, then it brings all the functions to that new contract. But what about variables? Variables are also inherited?
Yeah, I have shown you in the first example. We were discussing the data private and public variables. So I
sir.
have shown you guys here
Basically,
that
we were calling the functions.
I'm calling this dot info. You see, here I call this dot info because info is a public variable, and out of this contract, public variable even are called like a function.
Right.
Or if you want, you have to ignore it and like you have to call it like this, then it will not be available. This is not a callable, you see.
Okay. Thank you, sir.
Okay, so now moving to the interface. As we have seen the abstract contract, in case of abstract contract, what we have is we have some portion implemented, some functionalities have the implementation, and some functionalities that does not have implementation. That's why we have to create the contract abstract. But if we do not have any kind of implementation in any of the function, what we can do is we can create an interface which does not have any implemented function. All the functions will be incomplete and abstract, like this. The difference is, in abstract contract, we can also have the variables at instance level. In interface, we cannot have. In abstract contract, we can have implemented function few. In interface, we cannot. In interface, we can only have functions which is incomplete. So let's say if I create an interface,
So all the methods and functions will be incomplete in interface.
yes, basically. So let's say if I pick this function here. So first of all, it will give me error because all the functions inside the interface must have the access modifier as external. Another is they are by default virtual. You do not have to mention them virtual. They are by default virtual. So if let me keep it and see, you can see the error. Warning: interface functions are implicitly virtual. So it's a warning. So we can ignore that warning. Now we have, let's say, one more function. So we have two functions in an interface, and keep that contract abstract, keep it like this. Let's create another contract. and I'll say is calculator. Now I have inherited or implemented that interface into the contract T. Now it is giving me that it should be marked abstract because it has two functions which are not implemented. So either I can mark it abstract, but marking it abstract, that means we cannot initialize it, we cannot deploy that contract. So we wanted to provide the implementation of those functions. So let's say if I give the implementation of only one, it will still give me error because there is another function which is incomplete. So I'll add that as well. Now from the perspective of using them, let's say what we'll do is we have a two option again, like we do in case of inheritance. We have two options that either create instance of a contract D that's one, or what we can do is we can create reference will be the calculator and the instance will be the contract D. So it's again similar to what we have done with the contract. So the parent variable of a parent contract and the instance of a child contract, and you will see most of its implementation when in most of the DeFi projects, when you will try to explore some of the DeFi project, what happen is they have some implementation of interest rate calculation or some market policy which is different for different currencies. So what they do is they create a parent interface. So you have a parent interface, and sometimes a contract comes in with the implementation. Let's say the interest calculation for the DAI, or the contract interest calculation for the Ether, or another contract interest calculation for what you call USDC. So the parent function will have parent interface will have the single function, let's say get result, and the child contract which are implementing that interface will provide their own implementation. And whenever you wanted to change the implementation of an interest rate calculation or the currency calculation, so you'll pass that particular contract and the execution will be done based on this. So once we'll move towards the actual implementation of our functionality of a projects, then we'll see them in action more in detail. At this moment, we need to understand because at this moment we are covering all these fundamentals, that how these things work, what are these things, and how we can use it. We are not looking into them how they will be in action in actual project. So that's when we'll be implementing some domain functionalities, ERC 721 or something, some type of project. Then we will see them in action. At this moment, we can only see that there is a contract, some contracts inheriting, and there's an interface, another contract inheriting from the interface, the variable and instance. That's the base or the best we can see at this moment. Once we'll try to implement them in action, then you will see the right usage, or you'll understand more better why and how they will be used.
Sir, can
Okay,
you
so
mark
any
interface as an abstract?
interface itself, it's kind of an abstract because it is not a contract. Interface is not a contract. You cannot deploy it. It does not have a constructor. It does not have anything. It's just an kind of a what you call It's kind of
it
an
gives us
API. It's
okay.
yes. It's
So
kind
it
of an
gives us an
API.
outline that what should be in your contract, and that is must for a contract, that whatever is defined in an interface, it should be in contract anyway. Yeah.
In contract. So let's say we can have another contract which also implements the calculator, but that's the contract F, and that get result might be returning something else. So based on the implementation, sometimes we'll need implementation of contract D, sometimes we'll need implementation of contract F. So that's how you can do. And in case of blockchain, it's more it is more useful. Let's say you have a interest rate calculation based on some variables or based on fundamental. So what you do is you will create an interface, calculate an interest rate, and it has a function interest rate. And you have a contract which calculate the interest rate based on some variables. So you will provide that contract over to this interface. During the after the production, after the 2, 3, or 4 months of the implementation, you wanted to change the implementation. So what you will do is you will create another contract which will also implement from this interface, and you will deploy that contract. Now the implementation will be updated, and updated implementation will be used. So in your code, you will only worry about the interface, and if because interface will remain the same, contracts that are coming into it will always keeps changing. So that's how you can use it. And we'll see this in I'll try to create an example once we'll move towards the actual implementation, so that you can see the different contracts coming into the interface.
Sir, one more thing. Here
Yes.
we if you can go to code, please.
Yes.
Here we like we have inherited interface once again, but what if we inherit like contract F is contract D? So still these both functionalities should be in contract F, or we can change here the functionalities.
Now you do not have to override them because they are already available from the parent into the child. You do not have to. If you want to, then you have to make them virtual so that you can just that's how you need to go with it. So you have an interface, mark them virtual so that child of a D contract can override them if you wanted to go with this route.
Yes, thank you so much.
One question, Zishan. In addition to the interfaces, we also use a clause using this from this counter. For example, in case of the OpenZapland.
No, that's for the libraries.
Okay, libraries, and they are different than the interfaces.
Yeah, our next topic is libraries.
Okay.
So I'll explain in a moment.
Okay, thank you.
Yes, maybe the Namullah or Tariq, you have raised the hand.
Sir, can interface hold variables?
No, that's what I mentioned, that the interface cannot have instance variables, it cannot have the implemented functionality, it cannot have constructor. Interface cannot have them.
Okay, sir, Tariq, you go ahead.
Okay, so sorry. Okay, so as we are done with this interface, now let's move to the libraries. Libraries are basically when you wanted to have the reusable functions available to your complete project, and you have let's say you have some utility functions. You can see easily in case of an OpenZapland previously, before Solidity 8, there was no overflow checks in summation and subtraction and modulation. So what OpenZapland did is they created a library for the math function called safe math, and whenever you call the add function and you provide two variables, so the library checks it if it's an overflow or not, and then it gives you the final result. So it was just the simple mathematical addition, but it needs to check that if it's an overflow or not. So for that, what they did is they created a library. It's called SafeMath, and then you can use that library in your contract. So you can use create a library for yourself as well, and you can use that library into your contracts. So for that, let's come to another. So at this moment, I am for each example, I am not creating the separate files. So I'll be creating library here, and I'll be using library in the same file as well. But you can create a library in a separate class, and you can import that library or a contract like this. So you don't have to worry about the implementation. Library, and let me call it my math lib. Now here, what I can do is I can create function sum u into 56 a u into 56 b. Returns a plus b. So at this moment, we do not have any special functionality. We just wanted to learn how the library works. So that's my library function sum, and here we just okay. So one thing is what we can do is return my mathlib dot sum, and we can pass values 34, 56. That's the simple call of a library function library. Okay, so says can be restricted to pure. Okay, so we have a library called mymathlib. It has a function sum. It has it takes two input and then sum them and returns to us. So in our contract, what we can do is we can call this library just like this. Just try to understand that this file is not here. It's in a separate file. So what you'll do is you'll just call the import mymathlib.sol, and you will call like this. We just not creating the separate files, so you don't have to worry about this.
Sir, what is the benefit of a contract library or contract inheritance?
Basically, inheritance will be in case of inheritance, all the functionality needs to will be inherited in a particular contract. So the contract which will inherit from a contract can access those functionalities. In case of library, it's a utility function. So your domain must have some utility functionalities. So you will keep that utility functionalities into the library, and many of the your contracts can access those functions directly inside without inheriting. So these are the utility functions residing separately, and you can use them into your contracts.
Okay, thank you, sir.
compilation failed in override solidity. It's all 12. So 8. Line number 12. Get results. So 12. Okay. We are marking it virtual, I guess. Function missing override specifier. Okay, so I might have forgot to add this. If you are inheriting from the interface, then you do not have to mention the virtual keyword, but in the child class, you have to specify the override keyword. That's why the compilation is given the error. Okay, so it's compiled successfully. Okay, now we'll call the check result function, which is nothing unique. It does not have anything unique, which okay, so it's giving us the summation of the two variables. There is nothing special about it. But what you need to understand is the library is a utility library where you can add all of your functions, which can be accessed by multiple contracts. So this is one contract. I can create another contract and access that library directly, and functions are available at the single place. And all those contracts will use those functionality. And if I wanted to change something from that, I'll change at single place, and all those all those contracts will have that implementation. So these are the utility functions, which you can add into your library. So that's the one way to use your library into your contract. Another way is to, what you can do is the question someone asked before, after the interface, that you say using my MATLAB for UN 256. That means all the functions available in this library will be part of that data type, and you can call as a dot operator all those functionalities. So now here what I can do is I'll say UN 256 A equals to 12 and A dot sum 45. Now you need to understand that sum has two input variables. When you call this function with the name of library, then you have to pass both of the parameters, so that it will, both of these parameters will go over here. It will call the calculation and you will get the result. If you assign this library to particular data type, let's say in this case we are saying that matlab library for u into 56. So when you assign that library to a particular data type, then always first parameter will be for that data type. So if I'll do the boolean, it will not work. It will give us an error, because what we are trying to do is we are trying to say that apply this math library on u into 56. When we apply that math library on u into 56, then we can, all the u into 56 have the dot operator with the sum function, and the first parameter in the sum case, the first parameter will be this 12. So we are actually calling something like this. (12, 45). But because this library becomes part of u into 56, so it will be calling as a dot operator, and the variable which is coming from on which we have applied will be part of the first parameter by default. So you must have to understand, once you write the library and for which function you are trying to use it. So at this moment we have a sum function, and sum function accept the u into 56 as a first argument. So when you create using MATLAB for u in 56, so all those functions will become part of u into 56, and you can call it like this. That's how you can, the second way of calling the functions of library, the one someone is asking MATLAB for, using MATLAB for u into 56.
So sir, here in this case, it will be only available for 256 or 64, 32 other
No,
data
only
types.
be u into 56.
And if we declare it as using MATLAB for uint, then it will be for all.
Uint means u into 56. If you say uint, that means u into 56. Uint is an alias of u into 56, so that's no different. Okay.
And sir, one thing more I would like to ask, that there was a risk of overflow, then they developed this safe math library, but there is a library for, known as strings as well. So what was the risk with the strings they developed that library?
Which one? String?
Yes, string.
There was no risk. Basically, a string does not have the basic level of a string inside the Solidity, does not have all those functionality for the equality and the concatenation, and there are many features which we generally do with these strings, which are not available in the Solidity. So for that, many string libraries are available which do some these functionalities for us.
Thank you, sir. Thank you.
One more thing, we always keep library function as internal. When you keep library function as internal, that library become part of your contract, and it will count into the size of your contract. So let's say your contract has a size of 2 KB and your library has a size of 1 KB. So when you use the internal, so your contract will have a size of 3 KB. It becomes a part of your contract. If you make it public, then this function will, this library will not be called directly, and it will not be deployed directly, and you have to deploy libraries separately, like we deploy the contract, and then you have to link it. So I'm not going into the detail, that's not useful, but you can link it easily at the time of deployment of a contract. So you have to specify here in the contract to, so at this moment forget about it, but mainly we make it internal, so that library function become part of your contract. Okay, so any question for the library, so we can move to events?
Just one question. So if you
Yes,
have
yes.
multiple functions and you are using only one of them, so all the code of the whole library will it become the part of the contract code, or just that function
Yes.
that we're using?
Complete library.
Okay.
And sir, when if in case we are making it public, library we are making public, then any data we are sending externally, that will also be like library functionality will be applicable to that data as well.
It will working will be the same, but you have to deploy the library as a separate, like we deploy as a contract, and you have to use that address and link to the contract this library. So what you have to do is here you have a library and you have to provide the address of your library. So for that, again, you have to deploy that library separately. Like we deploy anything else.
Got it, sir.
So at this moment, it will not work because we have an internal function. So it will not work. I'm just showing you. That's how it will work. So you have to deploy that library separately and then link that library into the contract. Then it will work. If you have a public functions in your library, then.
Thank you so much.
Vishan, we have to see how much is left. Should we?
Just two topics. I can cover them today.
Okay,
The events and error handling. So we can cover it easily. So we can do it in next 30 minutes. Okay, so for the events, basically, events are basically whenever you wanted to raise inside the contract, you wanted to store some log information, you wanted to inform some external resources that you have some action has been taken place. So for that, we can use the event and we can fire the event. Event basically, can be fired within the contract, but no contract can listen to the event. So as you can see, an event is emitted, it stores argument in the transaction log. So whatever the transaction is being done on your blockchain network, event fires within the function, because event will be fired within the function, and event is fired in the function, that function will be the transaction. So it will be stored as a transaction log. So your events will be part of your blockchain. So it will stored in the blockchain. Let's say you create a variable which is local to your function, that variable will be destroyed. But when you fire an event, that event will store into the contract and it will be part of the blockchain, and you can access all those events at any point in time from blockchain. So what we can do is, let's say in this example, it is a call event is called deposit, and it's sending some values, and inside this function we are firing this event. So in our example, let's say we have Data updated. So that's my event. I name it data updated. And I'll provide the UN256 value. And inside, what I'll do is I'll create a function. Here at this moment, we are not doing anything, but we'll just emit the event. Let's say 56, comma, message.sender. So basically, we are firing an event. So whenever you will implement different functional, different domain, like if you are implementing the ERC20, ERC721, or ERC11, or any functionality in the DeFi, so if you wanted to update someone, or if you wanted to keep track of something has happened, what you'll do is you can fire an event, and that event will be part of the transaction log, and it will be available inside the blockchain. So let's say someone has minted a contract. So what you can do is you can fire an event that token has been minted. Someone has burned the someone has burned the contract token. So you can fire an event on the burning. Someone has just been added into your contract, so you can fire it. So you have different kind of functionality, and you can fire an event based on different functionalities. So at this moment, in our case, what we are trying to do is we are trying to fire an event, updated event, and when we call the do some work, so if you are firing an event, if you are creating a contract, if you are updating the state, then that function is not a normal view function. It will be a transaction function. Okay.
Sir Rahman is asking that if events are just for logging, and same is my question.
Basically, when you fire an event, they are become part of a transaction log, and from the external world, like from the JavaScript in your web application or on your server, you can listen to those events. So whenever some event occurred, you can listen to that event, and you can take some action based on that event. So you can use events for listening and taking action from external world.
Is there a cost associated with events, or we can use as many events?
Yes. No. There is a cost related to the event, because it becomes the part of your transaction log. I don't remember exactly the cost, but it is costly. That means it incur a cost.
Sir, can you explain the word listening? I didn't get it.
Listening an event is simply, let's say, on your website, you have a NFT tokens. Someone come to your website, click on the button, and minted a token. Now, what you wanted to do is you have a server. So whenever a token is minted, you wanted to update your database or something. So inside the mint function, what you'll do is you will fire an event. It will become part of your blockchain. And on the server side, what you can do is you can listen to that event. So whenever the event is being fired, you can listen to that event on your server. And based on that event, you have these parameters available. The value and the information, whatever the information provided to the event, you can use that and store into the database. That's the one example. You can do many things. Okay, so what we did is we call the do some work function. It fires the event data updated, the value 56 and message.send. Now when we print this receipt, it gives us all these functionalities. With it, we have this events, array of events, and it has the data whatever we send into this data at this moment. Basically, because we are using looking at the JavaScript point of view as a direct console.log. So you are seeing this data, you can extract that information separately, all those information. So if you see, this portion is first parameter, which you have sent this 56, but written it shows it hexadecimal number is 36, and this portion is the address which is being sent over here inside the data. And as you can see here, if you see, I have printed the receipt, and inside the receipt I have printed the events. So if you go through the only event object, you can see you have args array, and you see value and from. Value is the value which we have sent over here, this 56, and the from is the address. So that's the data available to you, and you can use those events to your functionality. At this moment, we have just used as a simple display, but you can listen to a particular event and it will give you the proper implementation, proper different values, and you can access them. So I'm not touching all the web application, so how you can access those events, but you have available those events in your web applications whenever you wanted to listen to them. So that's the simple related to the event. If you have any question, we can ask, then we can move to event,
Sir,
and you
I need to know
can
one
file.
thing.
Yes.
I need to know one thing, that like whenever an event is fired, so it is not possible that contract listens itself and then performs some other action by listening.
Contract cannot listen it. Contract only fires it. No contract can listen to it. It will only available to external world. So in your web applications or a server-side application, you can listen to them.
Okay, sir, thank you. And then after listening that, we can command to contract that you perform this section now, yeah?
Yeah, then definitely you have the ABI of a contract, and you can call function, whatever function of the contract you want.
Thank you.
Okay. So if Walaikum Assalam.
Events are a list of delegates. In C#, we see delegates, registers in events. Delegates is a address of our functions, or they are registered in event list and obsoleted. And when an event says file, or the delegates existed in a list executed. Can I write?
Basically, you have mixed 2-3 things into the one. In terms of C#, delegates are for the calling of a function. In here,
Right.
we are not calling any function. We are just firing an event so someone can listen to that event. We in C# delegates are, we are delegating a functionality or feature to some other function. So it's completely different from delegation, what we do with the delegation. So it's not related to this.
Right, sir. Right. Thank you, sir.
Okay, so the last thing, event handling. And I might have shown you guys in maybe previous class or the class before the event, what you say, error handling. So for error handling, what we have to do is whenever inside our function we wanted to apply some conditions and we wanted to check. So we have a 3 kind of functionality available. There is a 4th one, try and catch. I'm not going into that. Assert, require, and revert. They more or less do the same work, but they have some minor differences. That's why they are different and they have some different functionalities. So let's say I have a function called, just for the example, mint un 256, and it says number of tokens. Now, whenever we wanted to test an inputs or information which is coming from the input or which effect because of the inputs, we use the require to test it. So require should be your first line of defense inside your contract. So you wanted to test some conditions, and if those condition does not match, you will fire in, you will crash the application, you will throw an error. So let's say I'll say require number of tokens less than 10. See, so if if the caller will send number greater than 10 or equal to 10, then this require will check that if it isn't true, then the function will go on further and execute the further statements. If it's written false, then your transaction will fail and you will see this error message that your transaction has been failed and there is an error into your transaction. Let me just to show you, run this and we'll have all this over here. Okay, so you can see we have an error reverted with the reason string number of token cannot be more than 10. So because I have sent the information which is greater than or equal to 10, so our function will, so whenever you are receiving the inputs and you wanted to compare it with your state variable and all those things, then you will use the require and check those functionality. If your inputs are correct, if based on your input, if your state variables gets changed and your state variable will have some information which will not be acceptable, all those conditions which needs to be checked before executing your function, you will use require to test those functionalities, all those functionalities. So you can use require like this, or you can use require without any message. So if you do not want to send any message, you just wanted to revert your transaction, then just add the condition and do not send any message. So require and require with the message, both are same. The only difference is you can specify the message, so whoever received the error can see why the transaction getting failed. And because require works for simple conditions, so let's say you say the less than, greater than, equal to, all those functions. If you have a complex logic which can be implemented based on if else condition, so if you say if at this moment we do not have any complex logic, but if you have a complex logic, if number of token greater than 5 and number of token less than 10, if I'm just creating the trying to show that if it's a complex example. In such kind of a condition, if this condition does not match, we have to throw an exception. We want to cancel the transaction. In such case, we will call revert. Revert and require are exactly same. The only difference is require accepts the condition, revert does not accept the condition. Reverts will be used when you have a complex logic in your function, and on the failure of that logic, you wanted to throw an error. So when you have a simple condition, use require. If you have a complex condition, use revert, and revert can also be used with message. So we have like this. So both are same, just the usage of them are different. So that's the difference between require and revert. Both fails the transaction, and both are used for the checking the condition. Require will use for the simple conditions, greater than, less than, and quite less complex logic. When you have a complex logic, you will use the revert. Otherwise, both are same.
If we use revert, let's say after filing an event, will that event be reversed, or the event will remain
everything reverts? When a transaction gets failed, everything is reversed. There is nothing which stays into the blockchain, because transaction gets failed.
Yes. Okay. Thank you.
Okay. Now the last thing is assert. Assert is being used when you wanted to check if based on the action, based on the statement, based on this execution of your function, your state of a contract has been updated, and are they correctly updated or not. So assert is being used at the last, in the last of your function. So your last, at the end of your function. Generally we do not use it. Assert is being used less commonly. The most commonly used require, and whenever your function gets called, your first line of defense is the require. So check all the functionalities, but it does check inputs and change in your state based on that input. So you can say that if I'll add that number of token into my existing token, will it be the exceeding the limit or not? So that's kind of conditions we will do the require. With assert, what you'll do is it's also just check the condition. But if you say, let's say minting has been done over here and your token has been minted and something has done, now you wanted to see the total supply of my equal to or less than 10,000 or not. just showing you the example. We do not have this example. So what it does is everything has been executed. Your events, your statements, minting, or whatever the logic inside your function has been done. Now you wanted to verify the changes done to the states variables are correct or not. Then you will use the assert. For that, you will use the assert. Assert will also throw an event error, and it will crash your fail your transaction. And in those terms, assert, require, and revert are different, but you have to use them on the places where you wanted to use it. So require will be the first line of your call function call. Assert should be the last line of your function call. So, and require is used for the inputs, changes done based on your inputs. Assert is used for the state level variables. If they are in the right state, there is some erroneous things has happened, supply gets reverted, or anything on the state level is being corrupted, should be tested with the assert condition. And if it's corrupted, your transaction will fail. That's why assert is being used. All these things are for throw and error. And you can use whenever you want, whichever functionality, whichever keyword you wanted to use, based on the function we have discussed. Any questions? Yes.
So the require will be before execution, the revert will be somewhere in the middle of the execution if our logic doesn't meet the required conditions. And I'm thinking about the assert, because you said that the transaction will be revert. How, like, we have minted our blockchain tokens, like some tokens, ERC, somehow. So after this, it will check if the minted tokens are correct or not, and it will revert the transaction. So I'm thinking of how it will revert the transaction, because
transaction, you need to understand, and everybody need to understand, transaction is this function, mint function. If this mint function is completed, then the transaction is successful. If at any point in time in this function, there is a revert or there is an error, then the complete function gets failed and your transaction gets failed. So everything that is being done will be reverted. So that's the simple argument for this. So anything at whatever point, even at the last line of your function, if exception occurs or your transaction gets failed, everything will be reverted.
Will the funds will happen refunded? The gas funds will be refunded or not?
Sorry, gas fund?
Will the gas still be applicable?
Yeah, gas will be reverted. In the require and revert, gas reverted. In assert, the previous any previous articles and the documentation saying that assert does not revert the gas, but the I was looking at the new documentation. It was saying that assert is called the panic attack, and it was saying that panic previously was raising the invalid opcode. That's why it was eating up all the gas. Now it does not raise invalid opcode, but it does not say that it does not eat up all the gas. So based on that, I'm assuming that now it does not eat up all the gas. Even assert does not eat up all the gas.
Thank you. Thank you.
Okay, so I believe so. It's done. Related to this tutorial, and if we do not have any questions, so we can wind up over here.
Yes, sir, that was a great explanation of all this tutorial. Thank you.
Okay, then I think
sir, I'm sorry, but can I ask you a question?
Yes, please.
Sir, we were discussing about overriding functions, but somewhere I have read about super keyword and using the overridden function from the previous contract as the same function.
Sorry, can you repeat?
Yeah. So like I have read it somewhere. So we can use super keyword with the function which we are overriding, and we can use
to
its
call the parent
previous.
function.
Yeah.
Yes,
So,
yes, we can
it's
do.
okay. Thank you.
So basically, it's exactly the object oriented. So when you override a function, from this overridden function, if you wanted to call the parent function, then you use the super dot and you can call the parent function from the overridden function.
It means with the same function, we can have two implementation at the same time, but with using super, we can also use the previous implementation, right?
Yes.
Okay, thank you.
Okay, then we'll meet next week and take care.
सर
What? Yes.
सर मैं अपना क्वेश्चन उर्दू में पुट कर सकता हूँ?
Yes, please.
अच्छा सर, एक्चुअली बात ये है कि हमने ये जो है थ्योरम प्रोटोकॉल, इसकी 3 किस्में पढ़ी हैं, प्राइवेट, पब्लिक और कंसोर्शियम। इसके अलावा सर उसमें नोड की मुख्तलिफ किस्में हमने पढ़ी हैं, जिस तरह आर्काइव नोड्स होते हैं, वर्किंग नोड्स होते हैं, लाइट नोड होते हैं। इसी तरह सर हमने प्रूफ ऑफ वर्क, प्रूफ ऑफ अथॉरिटी और प्रूफ ऑफ